Hello, everyone, and welcome to CogNosco and Ascolto, the official scientific podcast of CogNosco Lab. This podcast series highlights our research in cognitive science and artificial intelligence.
Welcome to another deep dive. Today, we're going to be talking about how, toddlers acquire words.
Oh, cool.
We're going to be drawing on insights from a 2017 research paper.
Okay.
You know how kids kind of just learn language like magic?
Yeah.
Well, this paper kind of suggests that their brains create this complex web of connections between words that go way beyond just simple definitions.
It's super fascinating, right? This paper, it's called Multiplex Lexical Networks, reveal patterns in early word acquisition in children.
Wow, that's a mouthful.
It is. It was authored by Stella.
Okay.
And it was published in Scientific Reports.
Cool. So what is a multiplex lexical network?
So imagine a multi-layered map
Okay.
of words in a child's mind, their mental lexicon, and each layer of this map represents a different relationship between the words.
Okay. I'm starting to get a picture in my mind here, but I'm still a little curious about these different layers.
Yeah.
What kind of relationships are we talking about?
So one layer might be based on free association.
Okay.
So for example, if you say cat, what word immediately comes to mind?
Meow.
Yeah, exactly. Another layer could be feature sharing.
Gotcha.
So words like cat and dog would be linked because they share certain characteristics,
Okay.
like having fur and 4 legs.
So it's not just about what words mean, but how they relate to each other in different ways.
That's exactly it.
Makes a lot of sense.
Okay.
What are some other layers that they looked at?
Okay, so they also considered co-occurrence, which links words that are frequently heard together,
Okay.
like mommy and milk.
Okay.
And then there's phonological similarity, connecting words that sound alike, like cat and hat.
So it's almost like we're talking about multiple maps of a city
Exactly.
laid on top of each other.
Yeah.
Each map gives you a different perspective, but when you look at them together, you get a much richer understanding of the whole city.
Yeah, and it's in this case, the city is the mental lexicon.
Right. And
Yeah.
that's a cognitive construct.
Yeah.
Yes. Very important distinction.
Yeah. The mental lexicon, it's not a physical part of the brain.
Yeah, it's a theoretical model of how we use language.
Right.
It exists in the mind.
In the mind. Okay. So back to the research.
Okay.
What did Stella and his team find out about these multiplex lexical networks in toddlers?
So one of the interesting things that they found was that the structure of this network could actually predict the order in which children learn words.
Wait, hold on. So you're telling me that it's not just about kids learning the shortest or most common words first?
Right. It seems like toddlers are tapping into this hidden structure within language itself.
Whoa.
They're not just memorizing words randomly.
Yeah.
They're using these complex relationships between words to try and make sense of the world.
That's pretty incredible. And did they find out anything about how these connections become more or less important at different stages?
Yeah, so they observed 3 main stages of language development.
Okay.
The first one is called the very early learning stage, or VELS.
Okay.
And this happens before 20 months. Gotcha.
And in this stage, babies seem to be using a mix of strategies, drawing on multiple layers of the network.
Okay.
What's interesting is that the phonological layer, the one based on sound,
Right.
isn't very prominent at this point.
So they're not really tuned into those fine-grained sound differences.
That's one interpretation.
They're focusing more on meaning
Yeah,
and relationships between concepts.
exactly. Then between 20 and 23 months, you have the early learning stage, or ELS. Here, something called closeness centrality becomes key.
Closeness centrality.
Yeah. Imagine it's those words that are more conceptually close on that map are learned more quickly.
Gotcha.
They're figuring out the most direct routes between related words.
So the network is becoming more interconnected and efficient.
Yes, exactly.
What happens in the final stage?
After 23 months, they enter the late learning stage, or LLS.
Okay.
And this is where things get really interesting because free association takes over
Oh, wow.
as the dominant driver of word acquisition.
So at this point, they're making those creative leaps between words.
Yeah.
Like associating cat with lion.
Exactly.
It's almost like they're becoming little poets,
Yeah.
making connections based on similarities rather than just concrete definitions.
Exactly. This shift toward free association signals a significant cognitive leap in their language development.
Wow.
They're going beyond just labeling objects and starting to understand the nuances of language,
Right.
and the intricate web of connections between words.
This is all incredibly fascinating.
Yeah.
But I got to ask, what kind of data did they use to study this?
Right.
How do they create these multiplex lexical networks?
Okay, so they used a combination of different sources to create each layer.
Gotcha.
So for the free association layer, they used a database of adult word associations,
Okay.
which gave them insight into how words are connected in the minds of mature language users.
So they were basically using adult associations as a blueprint.
Yeah, precisely. And then for the feature sharing layer, they used a data set that categorizes words based on shared characteristics,
Okay.
like has fur, has 4 legs, or can fly.
So very systematic and detailed.
It is.
And what about co-occurrence? How did they know which words kids are hearing together frequently?
So that's where the Childies database comes in?
Childies.
Yeah, it stands for Child Language Data Exchange System.
Okay.
And it's basically this massive collection of transcripts of conversations between children and adults.
Oh, so they could see which words naturally cluster together in real-life conversations.
Yeah, exactly. What about the final layer, phonological similarity?
Right. What about that one?
For that, they used WordNet 3.0,
Okay.
which is a lexical database that has information on word pronunciation.
Gotcha.
They mapped out words with similar pronunciations based on phonetic transcriptions.
Okay, so they were able to identify words that sound alike based on their phonetic features.
Yeah.
It's a lot of data crunching. So now that we have a picture of how they built this network,
Right.
how well did it actually predict word acquisition?
So they were able to show a clear connection between the structure of this network and the order in which children acquire new words.
Wow.
Words that were more centrally located
Okay.
and well connected in the network
Uh.
were more likely to be learned earlier.
It's not just about memorizing words in isolation.
No.
It's about building these rich networks of meaning.
Yes.
Even as a toddler,
Exactly.
their brains are so sophisticated.
It's really remarkable how different layers of the network contribute differently,
Yeah.
depending on the stage of language development.
Right. You mentioned earlier something about this research having implications for AI.
Yeah.
Can you tell me more about that connection?
So imagine if we could build AI systems that learn language more like humans do,
Right.
using these same network principles.
Yeah.
Think of a chatbot
Yeah.
that not only understands your words, but also grasps those subtle connections between them, leading to more intuitive and nuanced conversations.
Instead of just responding to keywords, it could actually understand the meaning behind what we're saying.
Exactly. So this research opens up all these exciting new avenues for developing AI systems
Yeah.
that are more human-like
Right.
in their language processing capabilities.
I can already see the potential for this to revolutionize how we interact with machines.
Yeah.
Okay, so we've talked about these multiplex lexical networks
Mm-hmm.
and how they can predict word acquisition in toddlers.
Yeah.
But there's one more key concept from the paper
Mhm.
that we need to unpack. Preferential acquisition.
Yeah. So preferential acquisition is the idea that children are more likely to learn words that are more important or salient in their language environment.
So if a word has a lot of connections to other words in the network, it's probably more important and therefore more likely to be learned.
Precisely.
Okay.
It's like there's this popularity contest for words.
Yeah.
And the winners get learned first.
And this preferential acquisition plays a big role in the later stages of development.
Yes, particularly in the later stages.
That's fascinating. It's like toddlers aren't just passively absorbing language.
Right.
They're actively seeking out these key words, these
Yeah.
connections,
Yeah.
those building blocks of their linguistic world.
It's a remarkable process, and this research gives us a whole new lens through
Yeah.
which to appreciate the complexity and ingenuity of early language learning.
This brings us back to the potential implications for AI.
Yeah.
How could we use these insights to build more sophisticated language models?
Well, one approach could be to build AI systems with their own kind of multiplex lexical networks.
Okay.
So we could feed these systems massive amounts of text data to capture that rich tapestry of relationships between words.
So it's like we're giving the AI a head start,
Yeah.
providing them with a pre-built map of language.
Right.
But how would we teach the AI to learn from this network?
That's where the idea of preferential acquisition comes in. We could design algorithms that mimic how children prioritize certain words based on frequency, social and emotional cues, and grammatical patterns.
So we could train the AI to pay attention to how often certain words appear together,
Yeah.
to recognize cues in different social contexts, and to understand the underlying grammatical structure of sentences.
Exactly. It's like we're teaching the AI to think like a child, to learn language in a more organic and intuitive way.
By incorporating these principles of preferential acquisition, we could potentially create AI systems that are more flexible, adaptable, and nuanced in their understanding of language.
Exactly.
This has been a really enlightening deep dive into the world of early language acquisition.
It has.
We've learned about these multiplex lexical networks, the different layers of meaning they capture, and how they evolve over time. And we even touched upon the potential for AI to learn from these discoveries.
It's been fascinating.
But before we get too carried away, I think it's important to acknowledge that there's still so much we don't know about how language develops.
Absolutely. Every study, including this one, has its limitations.
What specific areas do you think warrant further investigation?
Well, so this research focused on typical language development. They used a standardized measure of vocabulary development. But, every child learns at their own pace.
Of course.
And in their own way.
And we can't forget about cultural and linguistic differences. This study was based on English-speaking children. I'd be so fascinated to see how these findings hold up across different languages.
Different languages have unique structures and sound systems, which could influence how children build their lexical networks.
It makes me wonder if these networks look similar across languages or if there are distinct patterns based on linguistic features.
It would be incredible to see like a visualization of one of these networks, to actually see those connections between words mapped out.
To see how it changes over time, that would be amazing.
There's actually a tool called MuxFizz.
Really?
Which is designed specifically for analyzing and visualizing multiplex networks.
Wow.
So we could put the data from this study into MuxFizz and see those connections come to life.
That would be incredible. We could see how words cluster together based on their shared features and co-occurrence patterns.
Exactly.
It would be like looking into a child's mind.
Precisely. And it could help us identify those key words, the hubs or connectors that play an especially important role.
It makes me want to go back to school and study computational linguistics.
It is a fascinating field.
Especially now that we're starting to understand the complexity of language development in a whole new way.
But even without going back to school, we can still apply some of these insights to our own lives. And to our interactions with children. We can be more mindful of the language we use around them, making an effort to expose them to a rich variety of words and provide context that's meaningful and engaging.
So it's not just about quantity, it's about quality.
Exactly.
We need to create those rich language environments that support vocabulary growth and comprehension.
And we can also encourage children to play with language.
Oh, for sure.
To make connections between words, to ask questions, and to explore the nuances of meaning.
It's about nurturing their natural curiosity and helping them develop a love of language.
Exactly.
And that goes for adults, too.
Oh, absolutely.
We can all continue to learn, expand our vocabularies, make new connections, deepen our appreciation for language.
Well said. This research is a powerful reminder that language is a dynamic and evolving system. And that we all play a role in shaping its future.
This has been a really eye-opening deep dive.
It has.
We explored the intricacies of early word learning. Uncovered these hidden structures within language itself. And we even touched upon the potential for AI to learn from all of this.
It's been a great journey, and it just highlights how important interdisciplinary research is. Where insights from different fields like developmental psychology can help inform advances in AI.
It's a reminder that we can find inspiration and knowledge in the most unexpected places.
Absolutely. And that there's always more to learn, more connections to make, more mysteries to unravel when it comes to the human mind and the magic of language.
Well, on that note, I think it's time to wrap up this deep dive. But before we go, I want to leave our listeners with a final thought. We talked about multiplex lexical networks and preferential acquisition as separate concepts. But in reality, they're deeply intertwined.
That's a great point. The structure of the network influences which words are learned.
Right.
And then the words that are learned shape the further development of the network.
It's a beautiful dance between the individual and their language environment.
Exactly.
And it's happening in millions of little brains around the world.
It is.
Shaping the future of human communication.
Until next time, keep those brains buzzing.
Yes.
And those words flowing.
Okay, so let's unpack these theories.
Yeah.
What are some of the factors that might influence which words children prioritize?
One theory is that children pay really close attention to how often they hear different words.
Makes sense.
Yeah, so words that are used more frequently kind of stand out.
Right.
And become more memorable.
It's almost like the mere exposure effect.
Exactly.
The more we encounter something, the more familiar and ingrained it becomes.
Yeah, and this frequency effect could be especially powerful in those early stages.
Right.
When children are just starting to build their vocabulary.
Because at that stage, every word is a potential key to unlocking new meaning.
Exactly.
But I imagine frequency isn't the whole story.
Oh, definitely not.
Are there other cues that children might be picking up on?
Yeah, so another theory suggests that children are very attuned to the social and emotional cues. Okay.
That come along with language.
Interesting.
So it's not just what's being said,
Yeah.
but how it's being said.
So things like tone of voice, facial expression.
Exactly.
The overall emotional context.
All of that can play a role.
Think about how parents talk to their babies.
Right.
They often use exaggerated intonation. They emphasize certain words.
Yeah.
And they pair language with positive emotions.
Exactly. So those cues might signal to the child that those words are particularly meaningful.
It's like they're highlighting those words, making them stand out. It's like when we learn languages as adults, we tend to remember words better when they're associated with a strong emotion.
Exactly.
Or a memorable experience.
Those emotional associations can make words more salient.
Right.
And easier to recall.
And there's one more theory I find particularly interesting.
Okay.
And it relates to the development of grammar.
Okay.
As children start to grasp the basic rules of their language.
They might start noticing patterns in how words are used grammatically.
Okay.
So can you elaborate on that?
Yeah, so imagine a child hearing the phrase, the big red ball, over and over again. They start to recognize that big and red are words that describe objects,
right,
while ball is the name of a specific object.
Okay.
These grammatical patterns kind of offer clues about the word's meaning and its function.
It's like grammar is providing a framework for understanding how words relate to each other.
Exactly.
And how they're used in different contexts.
It's a perfect analogy.
And this grammatical scaffolding probably becomes even more important as children start creating their own sentences, experimenting with different ways of combining words.
Right.
So we've got frequency, social and emotional cues, and grammar, all potentially playing a role in this preferential acquisition process.
Exactly.
It's like children are these little linguistic detectives.
Oh, wow.
Gathering evidence from multiple sources to try to decipher the code of language.
It really highlights that dynamic nature of early language learning.
And the resourcefulness of the human brain.
Absolutely.
Especially in those early years.
So this brings us back to AI.
Yeah.
How could we use these insights to build more sophisticated language models?
I mean, how could we?
Well, one approach could be to build AI systems with their own multiplex lexical networks.
Okay.
So we could feed these systems tons of text data to capture all those relationships between words.
Just like we see in children.
So it's almost like we're giving the AI a head start.
Right.
We're giving them a pre-built map.
Yeah.
But how would we teach it to learn from this network?
That's where preferential acquisition comes back in.
Okay.
We could design algorithms that basically mimic how children prioritize certain words based on all those things we've talked about.
So we could train AI to pay attention to how often words appear together.
Right.
To recognize those subtle cues.
Yeah. And to understand the grammatical structure.
Exactly.
It's like we're teaching AI to think like a child.
Yeah.
To learn language in a more organic way.
Precisely. By incorporating these principles of preferential acquisition, we could create AI systems that are more flexible, adaptable, and nuanced.
This has been such an enlightening deep dive.
It has.
We've learned about multiplex lexical networks, this concept of preferential acquisition.
Yeah.
And we even talked about AI.
It's been fascinating.
But I think it's also important to acknowledge that there's still so much we don't know about how language develops.
Absolutely. Every study has its limitations.
So what are some areas that you think need further investigation?
Well, for starters, this research, it focused specifically on like what we consider like typical language development.
Yeah.
They use the standardized measure of like vocabulary development. But
Right.
I mean, we all know that every child learns at their own pace. Exactly. And in their own way. Some kids might learn words in like a completely different order.
Right.
Than what's typically observed.
And factors like personality, learning style, and family dynamics could all play a role.
Yeah, for sure.
And of course, we can't forget about cultural and linguistic differences.
Right.
This study was based on English-speaking children.
Mm-hmm.
It would be fascinating to see how these findings hold up across different languages.
Yeah, different languages have different structures and sound systems.
Yeah.
Which could influence how children build their lexical networks.
Yeah, it makes me wonder if these networks would look similar across different languages.
Yeah.
Or if there are like distinct patterns based on those linguistic features.
It's a great
It
question.
would be so cool to actually see a visualization of one of these networks.
Yeah.
You know, to actually see those connections between words mapped out.
To see it all laid out.
Yeah.
There's actually a tool called MuxViz
What?
that's designed specifically for analyzing
Wow.
and visualizing multiplex networks.
That's so cool.
So we could actually take the data from this study,
Yeah.
put it into MuxViz.
And see those connections come to life.
Exactly.
That would be amazing.
Yeah.
We could see how words cluster together
Yeah.
based on their shared features.
And co-occurrence patterns.
It would be like literally looking into a child's mind.
It would. And it could help us identify those like really important words,
Oh, yeah?
the hubs or connectors.
That play a key role in the network.
Yeah.
Makes me wish I went back to school to study computational linguistics.
It's such a fascinating field.
Especially now that we're starting to understand language development in a whole new way.
Even without going back to school, though, we can still apply some of these insights to our own lives.
For sure.
And to our interactions with children.
Yeah.
We can be more mindful of the language we use around them, expose them to lots of different words,
Right.
provide a context that's meaningful and engaging.
So it's not just about quantity, it's about quality.
Exactly.
We really need to create those rich language environments that support vocabulary growth.
And comprehension.
And we can also encourage children to play with language,
Oh, yeah.
to make connections,
Mm-hmm.
ask questions,
And to explore the nuances of meaning.
help them develop a love of language.
Exactly.
And that goes for adults too, right?
Oh, absolutely.
We're all lifelong learners.
Yeah. Keep expanding your vocabularies,
Yeah.
making new connections,
Mm-hmm.
deepening your appreciation for language.
I love that this research is just a powerful reminder that language is this dynamic and evolving system.
It is.
And we all have a role in shaping its future.
Well said.
This deep dive has been truly eye-opening.
It has.
We explored like early word learning.
Yeah.
We uncovered these hidden structures within language.
Uh-huh.
And we even talked about AI.
It's been a great journey.
It just highlights how important interdisciplinary research is.
Absolutely.
You know, insights from developmental psychology can inform advances in artificial intelligence.
It's true.
It's a good reminder that we can find inspiration and new knowledge in unexpected places.
Absolutely.
Well, on that note, I think it's time to wrap up this deep dive.
Okay.
But before we go, I want to leave our listeners with one final thought.
Sounds good.
We talked about these multiplex lexical networks and preferential acquisition as separate concepts,
Uh-huh.
but they're actually deeply intertwined.
You're right. The structure of the network influences which words are learned,
Right.
and then the words that are learned shape the network.
It's a beautiful dance
It is.
between the individual
Yeah.
and their language environment.
This dance is happening in millions of little brains around the world,
It really is.
shaping the future of human communication.
That's amazing. Well, that's it for this deep dive.
It's been a pleasure.
Thanks for listening, everybody.
And until next time, keep those brains buzzing and those words flowing.